as we wrap up this module on confidence intervals associated with a single sample, it's useful to go to table 8.1 in your text, and we'll do a couple little notations on this one, but I encourage you to come up with your own table similar to this, but done in your own words that convey your understanding of the various different kinds of confidence intervals that we might develop, and what we're trying to get after them, and what the underlying distributions are that we're working with. For instance, when we're trying to develop a confidence interval for the mean, if we know the standard deviation, then if the underlying distribution is normal, and even if it's not actually, remember the sample mean by central limit theorem is going to be approximately normally distributed. If sample size is large enough, then gee, it's really going to be all end up being normal, right? So we can use, in essence, here the standard normal table to develop those confidence intervals. And so understanding what that is, this is a kind of notation that's useful, maybe putting out there what the two-sided versus one-sided estimates would be, how you would do that. For instance, z alpha over 2 times sigma over square root of n plus or minus, that sort of thing would be a helpful thing to jot down, have an all in one sort of place. As we go to where we don't actually know the standard deviation, but we have a large sample size, we can still use approximately normal here. Same kind of thing. Some people, such as your authors, say that bound to be large enough is 40. Some people say 30. Some people say it might even be as low as 20. I wouldn't go anything lower than 20. I'd be a lot more comfortable with 30 and very confident with 40. Okay. And then we go to, well, standard deviation is unknown, and we're going to estimate that with that sigma will be set equal to s, but what does that do to us? And big picture is we go into the t-distribution, and with n minus 1 degrees of freedom. And now that bound that we're dealing with is plus or minus t alpha over 2 if it's two-sided, and now it's s over square root of n that we're working with. So there's a regular pattern here that you see emerging in our approach. That pattern gets a little bit changed when we start looking at the variance, and now confidence intervals for the variance. Whereas before there were confidence intervals about the mean, but we came over here and what was going on with the variance, whether it was known or whether it was only estimated, potentially influenced how we developed the confidence interval. Now we're all about the variance itself. And so now we end up going to the Kite squared distribution, right? And that also has n minus 1 degrees of freedom. But that's an asymmetric distribution, and the way we were working with that statistic was a little bit different, and it resulted then in a slightly different way to write this bound, the plus and minus bound, so I'm not going to write that down. You might decide that you want to keep it. I just, for my own work, will tend to look that one up. Right? And then when you get to the population proportion, another sort of very convenient, commonly occurring one, and now we end up with approximately normal, and it has a very particular mean and standard deviation that's associated with it. I'm not going to write that out. There's again something you might want to do, collect it all at once, and how we write the bounds are similar. Again, you might want to fill that all in. Other things that you might want to keep track of here are relationship with the sample size for a given error range that you're interested in, how that might change across these different kinds of confidence intervals and situations. Very common situation that you might want to put here all together into one spot.